Hello viewers, I am Kausalya. Today we are going to solve our problem 1 in finding the Z parameters of the circuit. In the previously solved problems, we had used the basic formula V equal to IZ, but here we are going to use the two-port network parameters. So here you see, find the Z parameters for the circuit shown. So this is the given circuit diagram. So here we are having V1 and V2 as the respective voltage sources, and I1 is the current flowing through the input side and I2 is the current flowing through this side. So whenever you are asked to find the Z parameters, just write down the basic equation. So here V1 is equal to Z11 I1 plus Z12 I2, and here it is V2 is equal to Z21 I1 plus Z22 I2. So here in this case, we are going to find these four parameters Z11, Z21, Z12 and Z22. So initially I am making this current I2 as 0. When I2 is 0, these two terms will vanish and we will be having only these two terms. So what is the value of I1 here? Z11 is nothing but V1 by I1. Similarly, Z21 is V2 by I1. So here as a first step, you see, I had redrawn the given circuit diagram because here the thing is we are making the current I2 0, right? So I am just removing this part and I have drawn the rest of the resistors and voltage source. So here this is our diagram. So here what is the value of Z11? Here Z11 is nothing but V1 by I1. So here from this diagram you see this is your V1 and this is the current I1 which flows through this path. So to find the impedance, automatically we have to use the basic things, that is parallel combination of resistors and series combination of resistors comes into picture here. So you see this current when reaches this node, it gets divided into two and this current flows through this 4 ohm as such. So what does it means? That these two resistors are connected in series, right? Because there is no current division. And again that combination, okay, 2 plus 4 becomes 6 and that 6 comes in parallel with this 2 ohm because here the current gets divided. And again that combination comes in series with this 1 ohm. I believe you people remember all these things as it will take lot of time. Just I had written in a direct form, right? These two resistors are in parallel, okay? These two resistors means you have to consider this part also. So these two are in parallel and that combination comes in series with this 1 ohm. So what is the formula for parallel combination of resistors? It is 6 into 2 divided by 6 plus 2 and that combination comes in series with this 1 ohm. So plus 1. So once you solve here, we are ending up with the answer 2.5 ohms. So this is the value of impedance of this network. So here V1 is equal to I1 into Z equivalent. So we need only Z part, right? So V1 by I1. So V1 by I1 is equal to 2.5, which is nothing but Z11 is equal to 2.5 ohms, right? So the next parameter is Z21. So Z21 is nothing but V2 by I1. So here in this case, you see, here the current I2 is 0, right? So V2 is nothing but the voltage drop across this 4 ohm resistor. So here we are assuming let Ix be the current that flows through this resistor 4 ohms. So what about the voltage drop? What about the voltage V2 here? So V2 is nothing but I into R. Here the current is Ix and the resistance value is 4. Right. Now to find the value of Ix, we are using the current division rule. So what is the current division rule? Which is total current into opposite resistance divided by total resistance. So here what is the total current? I1 is the total current into here what is the opposite resistance? You see the current flows like this, right? So here the opposite resistance to this 4 ohm is taken as 2 because these two comes in series connection. Am I making clear? These two become series. So the resistor which is opposite to this 4 ohm is this 2 ohm. Therefore, opposite resistance is 2 divided by here the total resistance is 2 plus 4 which is 2 plus 4 is 6. And again 6 plus 2 is 8. You see 2 plus 4 is written as 6 here, and the total, in order to find the total resistance, you have to add this resistance also. So 2 plus 6. So here this is I1 into 2 by 8. So here which is equal to I1 by 4. This is the value of your Ix. So what is V2? V2 is nothing but Ix into 4. Now just substitute the value of Ix. Ix is I1 by 4. Here again 4 and 4 cancel. So V2 is equal to I1. We want the ratio of V2 by I1. So V2 by I1 is nothing but 1 ohm, because here we don't have any extra numbers. So we have to take here as 1. So V2 by I1 is 1 ohm, which means Z21 is equal to 1 ohm. Right. Now we are going to find the value of Z22. So here you see, okay, just like the derivation part. So to find the value of Z22, what we are going to do? We are going to make the value I1 as 0. You see, here we have calculated Z11 and Z21. Now we are going to calculate Z12 and Z22. Right. So here we are making I1 term 0. Once I1 is made 0, these two terms will vanish. So we can easily find Z12 and Z22. So you see, when I1 is made 0, okay, there is no current flowing through this path. And again, when you just look at this circuit, you see current will flow, it will flow here, it will flow here, and here it is an open circuit. Right, that's the reason why no current is flowing here. So what happens? Current will never flows through the open circuit path. Therefore, the current flowing through this 2 ohm will again flow through this 2 ohm. Okay, it won't get divided at this node. So when you draw the diagram, this is how it will look like. So here again what we need here, V2 is equal to Z22 into I2, and Z22 is nothing but V2 by I2. So here again, here that is V1, that is nothing, okay, it is 0 simply. Therefore here the thing is, we want to find V2 by I2. So here in this network we are having only V2 and I2. So automatically you have to find the impedance of this circuit, and you have to consider the current direction from this side. So at this node what happens? Current gets divided, and this current will exactly flow through this 2 ohm because these two are connected in series. So what about the total impedance? So here 2 plus 2 makes 4, right? And that combination comes in parallel with this 4 ohm. So 4 into 4 divided by 4 plus 4. Obviously here we are getting the answer 2. This is Z equivalent. So here V2 is nothing but I2 into Z. So the value of Z is 2. And here V2 by I2 is nothing but 2. And finally the value of Z22 is 2 ohm. Right. And here to find the value of Z12, which is nothing but V1 by I2. Again the same case and same scenario. So here what is the value of V1? V1 is nothing but the voltage across this 2 ohm. So let IY be the current that flows through this 2 ohm. Therefore V1 is nothing but IY into 2, that is I into R. So here how to find the value of IY? So again by using the current division rule. Right. So here the total current is I2 and current flowing through the opposite resistance. Again here these two resistance comes in parallel. Right. Here we will be having the circuit just like this. Here it is 4 and here it is 4. 2 plus 2 makes 4. So we want the current that flows through this path IY, and here the total current is I2. So total current into opposite resistance 4 divided by total resistance is 4 plus 4. So here it is 4 by 8, which is I2 by 2. So V1 is equal to IY into 2, right? So what is the value of IY? IY is nothing but I2 by 2. So just substitute the values here, and 2 and 2 get cancelled, and finally V1 is equal to I2. And again V1 by I2 is nothing but 1, right? Because here we are having no number, so we have to take number 1. So V1 by I2 is equal to 1 ohm, which means that Z12 is equal to 1 ohm. So here in this case, when you look at the things, Z12 is equal to Z21. That is, both the values are same. So this means that this is a bilateral network. So when you write the equations when you write the finally when you write the equations, you see v1 is 2.5 I1 plus I2 and v2 is I1 plus 2 I2. Right, just we have substituted in the equations. So that's all. If you have any doubt, let me know in the comment section. Thank you.